If you'd like to follow along, I made this notebook available on GitHub, so I'll send this link to the chat. And actually, Justin, can you send it? I don't think I can send it to all attendees. Oh, it just goes into Q&A maybe. No. Yeah, Justin, if you could forward it, that'd be great.
Yeah, sending that along.
Thanks. And then something that we can try to do, if you have some specific use cases that you don't know how to solve around analyzing market data, feel free to pop them into a chat. If you do it early enough, we may be able to implement them during this webinar and show them at the end. So what we're going to talk about is a Python library that is designed for analyzing market data. It's called OneTick PY. So you would import it just as you do with any Python libraries. This is just setting some defaults and figuring out which servers we talk to. So let's get to the interesting stuff. First, we're going to see how we can retrieve tick data. And we'll specify the name of the database. We'll be using New York Stock Exchange trades and quotes a lot. And also I will use CME data later on when we talk about order books. And we'll be looking at trades. So when we type this line, if we print it out, we'll just see that, let's just do that. We'll just see that it's a Python object. And what it's doing, it's building a query. And to execute the query, we are going to call otp.run method. We'll pass it the query. We'll specify the time range. So in this case, we'll be looking at the first 5 minutes of the trading day, and we'll be looking at SPY. And this will bring back as a pandas data frame all of the trades in the first 5 minutes on the 20th of April. And there are 17,120 trades. So, and you see the usual fields like price and size. Let's see what else you can do except for just pulling the data. So suppose you wanted to create bars. And we tried to keep the syntax as close to pandas as possible. So sometimes it may get confusing whether you're doing it in pandas or in OneTick. And the answer will be you are in OneTick until you call otp.run. And during this webinar, we'll be doing everything in OneTick. Yeah, for those who are not familiar, OneTick is a tick management platform that's used by some of the largest financial institutions for managing and analyzing tick data. So it's extremely performant. And all of what we're doing here is executed in the native OneTick language that's implemented in C++. It's executed on a scalable infrastructure, and it's parallelized as well using OneTick's native mechanisms for that. So let's just compute bars. The first line is the same. We are saying which data we're getting. We'll be looking at trades. Then we're going to call an .ag or .aggregate function where we'll be creating a field called volume where we'll be adding up the values of the size field from every tick, and we'll be doing it for the window size of 10 minutes or 600 seconds. And how do we know we're adding up? We are telling it to add up using this otp.add.ag.sum function. And similarly, we could find the maximum value in 10 minutes, the minimum value, the first, the last, and the number of ticks or number of trades in this window. So if we look at bars, and this is the last time I'll be doing it, but we're not seeing any data. We're just seeing a Python object. And we can execute it by calling otp.run. And now I'm looking at 1 week. So we're looking from 15th through the 19th of May. So that's all of last week from 9:30 until 4. I'm looking at the different symbol here, but it doesn't matter. And we're getting 10-minute bars with the fields computed here. And feel free to ask questions as we go along, by the way. Now, suppose you wanted to compute bars using only on-exchange trades during the regular continuous trading hours. So you could add a filter like this based on the condition that will basically get rid of everything that's not a standard trade during continuous trading. And then your bars would include only trades like that. You can execute this. This syntax is very similar to pandas. There is one slight difference. We are requiring a tuple as so the function, the filtering function, returns not just the filtered results, but also the else branch. So we need to put it in some variable. Most of the time, we're not going to need it, so we'll just use a placeholder for this. Yeah, and OTP.run returns the data frame. We'll talk about how it deals with different symbols in a minute. Or so actually, well, let's talk about this now. So here we looked at one symbol. Let's take a look at multiple symbols. So let's look at AA and SPY. So what is going to return now is a dictionary that's keyed by symbol, and then the value is the time series as a data frame. So let's just call it result for a sec. And I can look at result AA, and this is the AA bars, or result SPY. But what may be useful is to look at the merged time series, and you can do that in the following way. We're going to merge. So our query is called bars. We'll say that we want to merge the results, and our symbols we'll move the symbols definition to the place where we merge the data series. And now if we execute this, we'll get a single data frame where the results will be merged by time. And actually, to make it easier to digest, we need to say that we want to see the original symbol. So that's something called identify input time series. So if you run it again, we'll get a single data frame that has bars for AA and for SPY, and they're merged together by time. So this is the bar between 9:30 and 9:40 for AA, and this is the bar between 9:30 and 9:40 for SPY, and so on. And you can do it for many symbols in parallel. They're processed in parallel. You could specify not just two symbols, but you can say, I want to look at all of the symbols in this NYSE database. So for all of the US equities, for example. Okay, let's move on to the next use case. Oh yeah, multi-threading constraint. Yeah, no, let's go deeper here. So yeah, you can configure the defaults. In our case, the default is to use 8 cores, but you could specify it directly here to be whatever you want. Okay, now let's take a look at something that does not exist in pandas, but only exists in OneTick. It's a time-based join, so we're going to find the prevailing quote at the time of each trade. So let's take it step by step. First, we're going to look at trades again, and now we'll just look at 2 fields at price and size. And this is the same syntax you would use in a data frame. So I'm just executing this. We're getting the same number of SPY trades in the first 5 minutes, so 17,120. Now let's look at quotes, and we'll look at the NBBO. That's the database that we maintain. We'll just look at ask price and bid price, and we'll make a copy of the timestamp field in the quote time field. So let's run this. In the same interval, there are a few more, well, roughly 4 times as many quotes as there are trades. And we added this parameter, go back to first tick, to make sure that at exactly 9:30 there is a quote. So this looks back from the start time of the query to find the first quote before 9:30. Now we have 2 data series, and we want to join them. in a way that for every trade, we want to see the ask price and the bid price that was prevailing or that was in place at the time of each trade. So basically the timestamp of the quote should be as close to the timestamp of the trade, but preceding. And there is a function to do just that in OneTick that's called join by time. And you could think of this as enhancing trade ticks with the information from quote ticks. So this function takes a list of time series, and the first one is special. It's the leading source. It is the one that's getting enhanced. And all of the other ones are the ones that where we are taking fields to enhance the first one. And the join is by time, so it's the timestamp of the leading source that matters. So let's run this, and what we're going to get is, again, 17,120 records. So that's the same as the number of trades, but now every trade has ask price and bid price added to it, and we have the quote time, so you can check that it's always before the time of the trade.
Victor, while you're running through this, I've got a couple of questions coming in.
Yeah.
So one gentleman asks, he needs a link to our pip server.
Yeah, so you'll need a password for that. So I think if you email us, we'll send you a link with the password.
Okay. So if you email us at info@onetick.com, we'll send you the password for that. Same person also asked, do you have the whole package for macOS?
So it's the answer is yes. And yeah, so we have a whole package for macOS where the instructions will be the same. You still just pip install. So please, yeah, reach out to us. We'll send you the link. Yeah, there is a data question about trade time and participant time. I think in most of the time, trade time, the timestamp here is the collection time, and there is a separate field called exchange time. That's the exchange timestamp.
Good. Someone also asked earlier on, what about synthetic symbols such as SPY?
Not quite getting the question. So SPY is an actual symbol. But then synthetic, oh, it's SPY times 4. Yeah, I think that's what the question is about. Not sure. Let me get back to you on that one.
Good question.
But, okay, so we went through this enhancing trades with the prevailing quote. Now let's look at something slightly more sophisticated, where for every timestamp, so for every execution time, for example, you want to not just look at the prevailing quote at the time, but you want to look what happened, say, a second before, a second after, 5 seconds after, 10 seconds after, and a minute after. And you can do that using a very similar technique. So if we add 0 here, that would be what we just did. But now we want to look at other offsets or markouts. The beginning is exactly the same. We are specifying what we are looking at. We're looking at trades. And then we're going to look at the NBBO again, but now for every value of the markout, so for those 5 values, we're going to shift the time series. So it basically looks at this offset, either back or forward. And then when we do join by time, it will return us exactly what we want. It will return us the best bid and best ask, for example, 1 second before the execution or 1 minute after the execution. And this just takes a few lines of code in OneTick PY, and this function join by time is taken a list as I mentioned. So the first one is the leading source, and then all of the other ones, in this case, 5 NBBO sources will be the ones that we are using to enhance the leading source. So when we run this, we're going to get for every trade. I looked at a different symbol now, so we have a different number of trades here. So, but there are over 700 of them here. So for every trade, you're getting the ask price and bid price a second before, and you can check the timestamps a second after, 5 seconds after, and so on. Now, another common use case is to look at interval metrics. So suppose you want to compute the market VWAP in a given time period. Let's just start slow. So we're specifying, again, the data source. It's the same NYSE tech trades. And we're going to compute the aggregation. The market VWAP will be the name of the field, and we'll be using the VWAP aggregator using fields price and size. We can just run this query by providing it the time range and the symbol. It gives us the answer. What's more useful is to compute it for every order. So we'll just generate two orders here, and we'll just use arrival, exit, and symbol fields from the orders. And now we can write code that will compute the VWAP between arrival and exit for every order. So to do that, we're going to create a function called VWAP, and it's doing exactly what we just did in this simple example. So these two lines just migrated here, and we're returning this query as the result of this function. And then for our orders, so for the two orders that we created, we're going to call a join with query function that takes the VWAP function we just defined, and that tells it the time interval that it should be looking at. So that's how the VWAP function knows about the start and end time, and also the symbol. And now when we run this, we'll get those two ticks, but they will also have the market VWAP field. So this market VWAP was computed as the market VWAP between arrival and exit for Apple, and this one between arrival and exit for Microsoft. So here there are a few questions. Is the API available via JavaScript? We offer, this API is a Python API, but we offer just a few REST endpoints for things like I'm showing you now. So if you just want VWAP and markouts, then there are endpoints for that, and you can call that from any language that you like. Then Python pandas code gets converted to OTQs, C++. So OTQs is the native OneTick query language. Can use native Python syntax in the code for processing data. So this is a somewhat more sophisticated question. I think I can point you to documentation. We expose, so some of the functions that are right here, it supports a subset of the syntax of Python syntax, but it's pretty expressive. All right, now let's take a look at another use case. And I'm going to go to another notebook for this. So we'll see how this works in real time. I have some real-time data being replayed here. So if I execute the cell, and if we just look at the timestamps here, actually, let me start this again. No, I want to be here. Yeah, so I just want to show you that we have real-time data. So it's 20 minutes, 25 seconds past whatever the hour is. Ignore that it says 16 here. So if I execute it again, it's 20:35. It's 20:39, so it's ticking. We are getting real-time data. We're just looking at the 5 most recent trades. And against this real-time data, we can define a moving cross strategy. So what we're going to do is we'll define 2 moving averages, the short and the long one. Actually, this is going to be 5 minutes. And well, the relevant numbers are here. So 60 seconds and 5 minutes. So by now, when we computed bars, we already used the aggregator. So now we're just taking the mean of the price. We're specifying the 1 minute interval, but now we're going to compute a sliding average. So it's going to be a sliding window of 60 seconds. And similarly, we'll compute the long-term moving average. It will be a sliding window of 5 minutes. And then we'll define our signals. We'll be buying if in the previous tick, so -1 takes us to the previous tick, the short-term moving average was below the long-term, but in the current tick, it is above the long-term. And symmetrically, we'll define the sell signal. So let's execute this. So far, we're just defining the moving cross strategy. Now we're going to define our callbacks. So when we run this moving cross query, it will be communicating with us via callbacks, and the callback is executed on every tick. So as every new trade arrives, this method is being called, and that tick is passed to this method. And so what we'll do is we'll just print a dot for every trade. And then if there was a signal to buy, we'll print the word buy and the full tick, and similarly for sell. So again, so far we're just defining the callback, and now we can actually run this query. So we instantiate the callback. We're using otp.run. We're passing it the query. So the TRD query we defined here that looks at moving averages. We are passing it the callback. We are saying that this is a continuous query or a CAP query. So running is true. The end time will be sometime in the future. And let's run this. So it started in the past, but it's running up to the current time. And then at some point, it will reach the current time and it will be ticking trade by trade. So if you can see my mouse pointer, it's outputting a new dot for every trade. And every once in a while, it would output the signal. So this is the tick when it decided to buy. So when short-term crossed long-term from below, and previously it crossed from above. So that's the sell. And so this is running real time now. And so kind of a cool thing about this that you're using the same language, the same functions to define your historic and real-time queries. Okay, let's now take a look at order book. And we'll be looking at the CME data. First, just to show what we're looking at, we'll be looking at E-minis for the next expiry, so for June expiry. We'll pick a time for the order book snapshot. It will be 10 a.m. Eastern on the 22nd of May. And let's just take a look at, one way to look at the order book, which is called OB snapshot. And it takes max levels as a parameter, and it outputs top 3 levels for the ask and bid sides. So this buy sell flag tells you whether it's ask or bid. And 1 means ask. So it's so the values here will be increasing. So this is the best ask. Then this is the second level. This is the third level. And 0 stands for bid. So this is the highest bid. This is the next highest. This is the third highest. So that's one way to visualize the book. And this is a snapshot at a given point in time. We could also look at the same snapshot, but in a slightly different format that we call wide. This is where every tick responds to a level. So now every level has a bid and ask. So instead of 6 ticks, 1 per level per side, we're getting 3 ticks, 1 per level, if you're just looking at 3 levels. And we could also flatten it even more to get this OB snapshot flat output, where all of the 6 pairs of values, pairs being bid size, ask size, and the time actually, are displayed in the same tick. And this 1 corresponds to the first level, 2 to the second level, 3 to the third level. And depending on your use case, it may be convenient to use one of the 3 methods. What you can do with this, in particular with order book snapshot flat, is you could look at all of the changes to order book. In this case, we're looking at all of the changes to the top 3 levels, event by event. So we're not doing any bucketing. And we could see how it changes. So we're just adding running equals true, and we're expanding our time range from just a snapshot time to 100 milliseconds. And now when we run this, we're going to get every update. Whenever an update happens at any of the top 3 levels, we're going to see the corresponding tick. There's one or more of the values updated. And so within 100 milliseconds, there were 433 changes to one of the top 3 levels. You could also look at all of the levels in a book, and for that you would need just OB snapshot. So if I don't specify max levels, then we can see that at 10 o'clock, there were over 2,200 levels in the book for Nasdaq E-minis, which is pretty deep. So let's actually do something with the book data. Let's compute book imbalance. So we're going to look at just 3 levels, again, for the purposes of to make it easier to digest, but you could specify whatever number you want here, or you could specify it as distance from the top of book. So we're going to look at the top 3 levels. We're going to add up the total size on the ask side, the total size on the bid side, and we're going to take the ratio. So we will be dividing the sum of the bid sizes by the total size. And the value close to 1 will mean that most of the volume is on the bid side, close to -1 on the ask side. But let's go, and this will make more sense hopefully once we go through this. Let's just first look at the book that we'll be analyzing. I don't need this. So these are the top 3 levels. Let's compute the ask and the bid volume. And we can check that the top 3, so we're doing this using this OTP .ag sum aggregator for ask size and bid size. So this is the input data. This is what we're doing to it. We are measuring we're aggregating based on the number of ticks. Because we're using OB snapshot wide, we know that every tick corresponds to a level in the book. And so here our bucket interval is just the number of levels that we're aggregating over. If we check the sizes here, so ask volume is 21, and if we add up 5, 7, and 9, we'll get 21, and similarly, if we add up bid sizes, we'll get 19. And then we'll just normalize this. So we'll take the difference between bid volume and ask volume and divide it by the sum of the 2 volumes, and this will give us this imbalance value. In this case, it's below 0 because the ask volume is higher than the bid volume. And we could create stats for this value by running this over a time period and looking at how the imbalance value changes. And actually, for this, I need to specify let's skip this example. But what you can do is we could produce the metrics, this imbalance metric for every window, and then you could take statistics over a number of windows that you care about. Let's move on to another example. That's a book sweep. So suppose you want to find out if you're ready to pay a certain amount, what is the total quantity you can get. That would be sweep by price. So it will take the side and the price, and it will give you the total quantity available instantaneously if you were to execute against the book. And we'll just define a function that takes us from side to either +1 or -1. So this will help us deal with this, with equations like this. So we're going to look at order book snapshot. So here, order book snapshot is this example where we have a separate tick for level and side. So we'll just be looking at either buy, either ask or bid sides. And we'll take the price as an argument, and we'll just be looking at the levels that that the price can reach. So the price is supposed to be aggressive, but it can reach only certain levels. And this equation says that as long as the price is more aggressive than the current level, we are going to include the quantity from that level. So that will be adding up the size. Let's execute it. So if we pass it, that we are going to execute against the bid side, so in order to sell, and that we are ready to pay up to, if our price has to be at least 13,927, then this is the total volume that we'll get. And similarly, you could ask, if I am buying and I'm ready to pay up to 13,930, this is the total volume I can get. And similarly, you could ask, what would be the VWAP if I wanted to execute a given quantity? This is very similar, a little bit more complicated, because you need to deal with the case when your quantity does not map to a fixed number of levels, but it basically lands in the middle of a level. So if you want 10, but at the first level you have 7, at the second level you have 5, so you just want 3 from the second level. But otherwise it's the same, and we can ask the same questions. If I am selling and I want to sell 10 right now, this is my VWAP. If I am buying and I want to buy 10, this is my VWAP. All right, this was a very quick overview of some of the analytics functionality. Now we'll take a look at what else we have, mostly around data. We have support for corporate actions built into this API. So let's just look at an example. MKD had a 1-to-15 split on 23rd of May last year. And if we just look at the data from the 20th of May to the 24th, it looks like it jumped. So this was the weekend, but the price was around 0.1 before the weekend, and it was around 1 after the weekend. We could apply corporate actions to this, and that is done just by calling the corp actions functions from OTP, and we would let it know that we want to adjust the price, and we want to pass the adjustment date. So basically, we want to be looking at prices in the units as of the adjustment date. So in this case, we chose 24th, so that's after the split. So we would expect prices to be around 1. The rest is exactly the same. Let's run this. And now we get a much smoother price curve that is around 1. Alternatively, we could look at the units before the split. So if we run this, then we'll expect prices around 0.1, which is what we see. And you could apply the same to volume. You can actually see we have the corporate actions data. So you could query corporate actions for a symbol. In this case, if you just query it for MKD for a few years, so looking at 3 years here, then we can see this split. If you want to see more corporate actions, we could look at Apple, for example. and Apple had quite a few core protections in the last 3 years. Now let's look at symbologies. We support different symbologies. I'll show you some of the examples, but we're back to Noisy tag, and now we'll just use different symbology to query the data. So we were using the ticker before, so the symbols equals Apple, but we can get the same data if we use BTKR, which I think is Bloomberg ticker. We get the same tick. And here are some of the other symbologies that we support: CDALs, FIDGES, ISINs. Something that's very easy for us to do is to create a mapping between different symbologies. So for example, here we'll create a mapping between FIDGES and BTKR. So we'll get a map from, well, let's execute it one time. So we can get a map from the FIDGE to the symbol name, to the ticker. That's the original symbol name, is how it's stored in the database. So most of the time it will be the exchange traded ticker. We can do the same for Bloomberg, and now we get this. And now we can join the two using original symbol name. So with a few lines of code, we can go from FIDGE to Bloomberg ticker for every symbol. We can do the same for any equities markets, so they don't have to be US markets. This is looking at something on the London Stock Exchange. And here, not something that's looking at all of the symbols actually. And we are mapping exchange traded ticker to a FIDGE. Symbol name changes are very easy. So Facebook became Meta last summer. So if we want to use the symbol Meta, we just say that the symbol date is any date after the 9th of June last year. For example, anything in 2023. If we want to refer to it as Facebook, we'll just pass symbol date before the summer of 2022, like 2021, for example. And here I'm querying the same data, but using Facebook as the symbol. But we get exactly the same data. So this is basically the as of date for the symbol, but the data doesn't change. We also have daily data, including official closing prices. If we were to look at just one ticker, say Apple, it could look like this. So we're looking at 5 days of daily data here, including closing prices. But we could also look at a lot of this data quite fast. So we have our own OneTick ID. That's the fastest way to query this type of data, and that does not that doesn't change basically. So you don't need to worry about symbol changes. And this code is going to return us 5 days of daily data for all of US equities, and should be pretty fast. So I just started it, and yeah, and here it is. So 60,000 sounds about right, roughly 12,000 tickers traded for US equities times 5 days. And we have capitalization data, yeah. Historic as well. Now I'll very quickly show you another library that we developed that's designed to make machine learning easy when you have your market data, when you use market data to prepare features. And let's just take a look at a very simple example, and there will be just one cell, so don't go away. That will cover. We're going to predict trading volume in the next 10 minutes. And this is basically just one sample of what trading data looks like. So it goes from 9:30 until 4, and this is this U shape where there is more trading at the beginning and at the end of the day. And our goal, if it's 10 o'clock now, we want to use any of the data that we have so far, so any of the data until 10 a.m. to predict trading volume between 10 o'clock and 10 past 10. And so this could be useful, for example, for your execution algos or for specifying parameters to your for your algos and brokers. So if you wanted to do an experiment that does volume prediction, you could do it all in one cell. Let me make it fit on one cell. I'll cheat a little bit, make this smaller. So we're going to look at half a year of data. And the things that we make very easy to do are things that are specific to time series and specific to market data. So we're going to split our data using split it by time, and we specify the time splitter method that lets you just specify the cutoff where your training data stops and validation data starts, and where your validation data stops and test data starts. Then getting data is done basically using this OneTick PY language that we showed. So in this case, we already have 1 minute bars data. So we'll be looking at 1 minute bars, but we'll aggregate them into 10 minutes. And then you can specify a pipeline, and the pipeline will be specified using OneTick whenever it's appropriate, but then you can go into pandas. So you could say at this point, I want the pipeline to continue in pandas. In this example, it's all done in OneTick, which is normally much more efficient. So what we're going to do here is we're going to use lagged values we are predicting volume in the next 10 minutes, and we're going to use a lagged value, meaning lag 1 is the last 10 minutes. What was the volume? If we are predicting it at 10 a.m., what was the volume between 9:50 and 10? What was the volume between 9:40 and 9:50? And 39 corresponds to 10 a.m. on the last working day. So what was the volume between 10 and 10 past 10 on the last working day? So this will become our features. We'll also add or try adding some other features like the identifier of the current period, like 9:30, 9:40, the symbol itself, and we'll apply the logarithm to all of the volume values. And then we are saying that our target, what we are predicting is volume. Our features are all of the lagged values plus the identifier of the time period plus the symbol identifier. And we'll try LightGBM and XGBoost. And I will be trying different parameters. So we'll try all of the combination of those num leaves and max depth. So 3 by 3, there will be 9 combinations here, and 3 combinations for XGBoost. We'll be using walk forward validation. So that's what's appropriate for time series. There will be 5 folds, and we'll be using mean absolute error for the validation. And then we want to see the following metrics on the test set. We want to see symmetric MAPE. We could add MAPE here, mean absolute error, RMSE, and R squared. So this specified our experiment. And now to run it, we instantiate it and call that run. And I can execute this. Actually, this we have the ability to run it on a cluster. In this case, we are not. We're just running it on one machine, but it's still pretty fast, and it will come back with an answer, I think, in the next few seconds. But this is something that can be very helpful if you need help managing your machine learning experiments, getting features out of market data. We also have an MLOps infrastructure around it that helps you retrain the model, monitor the model, serve the model to production. We have a working example where we are posting volume prediction for the next day on Twitter, so you can review that with us if that's of interest. Okay, we're not going to wait for it to finish. We'll just come back to it in a second. So how can you try this? And there are different ways in which you can try this. There is a OneTick PY via REST API where you're limited to whatever endpoints we expose, for example, market VWAP and point in time. And they support a variety of data formats. So you could be querying just by making one request at a time, or you could submit a CSV file that contains, say, 50,000 orders, and you'll get back a response that enhances those 50,000 orders with the corresponding metrics. Mention that you're interested in OneTick PY REST API, if that's what you're looking for. If you want to be able to play with OneTick PY the same way I did in these notebooks, you can pip install it. And you don't need to install OneTick for this. You just install OneTick PY, and we configure your access. So you'll be writing code on your side in your whatever it is, VS Code, Jupyter command line, anything. But you'll be making calls to our tick servers. So all of the computation, all of the market data is on our side, and then you're just getting back data frames. And we have over 200 exchanges with market data that you can play with, and most of the time, more than 10 years of historic data. You can review the documentation for this. It's available online. The link that I think Justin made available to GitHub has a link to documentation. And if you're already using OneTick, then for you, it's just a pip install command, and you can follow instructions in the documentation. Let's just come back here real quick. So it did finish. It computed the metrics. If you want to, so we computed metrics for those 5 symbols. If you want to break it down by symbol, we just ask calcmetrics to group by, to use the group by column, that is the symbol name, and now we can see the breakdown by the symbols that we specified. And you can get, so if you want to play with the machine learning package, the easiest way might be to use our hosted Jupyter Hub. So the same way what I'm using now is Jupyter Hub environment. We could create one for you, and you could use it there. But for a production use case, we'd have it deployed on your site. So it's also a pip installable library.
Thanks, Victor. So now's a great time for the audience to submit questions. We've had a lot of questions during the course of the webinar, and the team here has been busy answering those questions. So let's go through a few questions we didn't answer during the course of the webinar. Is the normalized market database using direct feeds, or SIP, or in combination?
I'll have to ask our data team. I think it's SIP, but we'll get back to you.
Good. Next question. Can you obtain historic market capitalization data for equities?
Yes, I think we answered that. Yeah. So we have shares outstanding, and it's updated as often as they change.
Same gentleman asks, can you substitute a QSIP in lieu of a ticker?
I'll have to get back to you on that one, but generally we can support any symbology. So we have a way to ingest different symbologies, but I think QSIP may be related to some licensing issues, but in general, I think we support it.
Excellent. Someone else asks, how do we get OneTick-DS-framework package?
Yeah, I just covered that.
Perfect. Another question here. Can you show order book imbalance calculations in real time, just as you did with Moon?
Oh, yeah. Thanks for that. Well, let's come back to that. I think that's a good thing to try. So let's go back to the order book here. All right, here it was. So order book imbalance computation in real time. Okay, let's go back to this. Let's turn on running equals true again. I think I was wrong removing it. So now we'll have many more lines as output here. Why am I not seeing it? Oh, because I plugged in running equals true in the wrong place. So we don't want to run a real-time query. We want the order book, the historic order book, to be displayed in the running mode, meaning tick by tick. Whenever there is a change to the top 3 levels, we want to see the book again. So now in this 100 milliseconds, they're getting 6 lines, 6 meaning 3 levels times, no, it's wide, getting 3 ticks for every timestamp. So you'll see the same timestamp 3 times corresponding to level 1, level 2, level 3. You can see it in the level column. So it will always go 1 to 3, 1 to 3, 1 to 3. And for each 1 to 3, the timestamp will be the same. And anytime there is a change to any of the fields at the top 3 levels, there will be a new 3 ticks will appear. So let's now carry on with this exercise. Let's compute imbalance. So at this point, we're just computing ask and bid volume in a sliding window. And I didn't need to change anything here. I just changed I just set running equals 2 at the order book data source level. So now we're operating with this data and we're computing ask and bid for every 3 ticks. And as we just discussed, basically 3 ticks correspond to 3 levels of the same book. So we're getting this output. And now we can just, based on that output, we can compute the sliding values. This is the imbalance. And now you can get more meaningful stats for time weighted average, for the mean, and for the standard deviation. I hope this answers the imbalance calculation question. And all of this could run in real time if we had real-time book data appearing. Okay, Justin, back to you then. Okay,
right. Well, thank you so much for attending our webinar today, all the questions, answering the poll. As always, to learn more about OneTick, please visit onetick.com, email us at info@onetick.com. And thank you to Victor and his team for answering all the questions. And we look forward to seeing you all on the next webinar, sharing more details about OneTick PY in the future. Thank you all.